Right. Hello friends, welcome to Coding Garden with CJ. In this video, we are going to implement a linked list from scratch. We're going to talk about what a linked list is, and then we're gonna write it. We're gonna write some code that does it. Now, I have not prepared at all. The chat has voted on what we're gonna do, so I'm gonna search Wikipedia for linked list. Let's see what we can find out about it. Oh hey, it's Wikipedia's birthday. Happy birthday, Wikipedia. In computer science, a linked list is a linear collection of data elements whose order is not given by their physical placement in memory. What just happened? Some sort of alert happened? I don't know what that was. Did people hear that? I heard that. Whatever. Okay. It's a data structure consisting of a collection of nodes which together represent a sequence. Fantastic. Let's get some code going. So, algorithm of the day. That's a thing. And we're going to make a directory for linked list. And we'll open this up with VS Code. Content. Okay, let's just create a file for now, index.js, and let's write some stuff. Now, if we look at that definition, it's a data structure consisting of a collection of nodes. Now, let's actually just start off with a node. So we need something to represent a node. And I guess, you know, since we're here, we'll use object-oriented programming. We'll use separate files. So let's literally I was gonna say, we're gonna create a file called node.js. Now, just to be clear, I'm gonna call this a linked list node.js, because this is not node, this is a linked list node. Okay, so, I'm gonna create a class called linked list node. So this class is going to represent a node in our linked list. Now, what does a node have? If we look at the Wikipedia definition, in its most basic form, each node contains data and a reference to the next node in the sequence. So our linked list is just going to be a linked list of numbers. It's going to be super simple, but we'll have a constructor for this, and this will take in let's call it data, just like they do on Wikipedia. So this node has data, and I guess do we pass in the reference to the next one, the previous one? I guess we don't. I don't know. We'll figure this out as we go. But let's just start here. A linked list has data, and so the constructor takes in data, and we're just going to add it as an instance property. So I'll just say this.data equals data. And what that will do is that will allow us to create a bunch of instances of nodes. Each of those nodes will have data in them. And let's just do that in this file here. So I'm in index.js. I'm going to import in this linked list node right here. So we'll call this linked list node. And we're going to require in the file we just created, linked list node. Now, because this is a class, we can create instances of it. We need to export it though. So we'll say module.exports equals that linked list node. So this exports this class. This file brings it in, and now we'll create an instance of it. So let's just call this some node. And we're going to create a new linked list node. And the constructor we created takes in data. So we're going to pass in some data here. Let's say this linked list node has the number 42. Great. We have created an instance of a node. Let's just log that out like this. And let's see what happens. I'm going to run this code in the terminal. There we go. So we have a linked list node that has the data 42 inside of it. Let's create another node. Let's do like some other node. And this is going to have the value 13 inside of it. And then here we're going to log some other node. And if we run this code, now we have two different nodes. Now these two nodes are totally unrelated. It's just a little node. It's got a little bit of data inside of it. I am going to attempt, again, something on the fly that I did not prepare. We're going to maybe draw a diagram. Let's see. Let's go over here. That is surprisingly in the center. And it works. Okay. So we'll use a different color though. That was a little bit hard to see. Well, let's think about it like this. So we have a node, right? We have that sum node. Let's we'll look at a node and we'll think about it as just like a little box, right? And that box has a value inside of it. So this node has the value 42, and then we created another node and that had the value 13 inside of it. Right now, these two things are totally unrelated. They're just in memory, right? It's two little nodes in memory. What a linked list does is it connects these nodes together. So basically, if we wanted to turn this into a list, we could say that this node points to this node. So the like the next value, this is we'll get there. Let's get like a nice, yeah, there we go. Nice big arrow. So this node points to this node. And then if we created another node, so let's create a node with the value 7 inside of it. And we could say that this node points to this node. Great. Now we have a linked list. We have this node, which points to this node, which points to this node. And we could, yeah, nice arrow. Thank you. And we could iterate this list, right? Like if we know where the list starts, like the list starts here, we could go to that node and we could say, hey node, what's your next node? And it points here. And then we're like, hey node, what's your next node? And it points here. So this is a linked list. And then we could say that this is the tail, the thing ends here. I think people draw it like that. I don't know how to draw the beginning, but we could call this the head of the list. We could call this the tail. This is a linked list. Yeah. Well, focus mode isn't done. We just switched to the other screen. I don't know. Okay, so this is a linked list. So this is known as a singly linked list, right? Because each node links to each other. But you technically could have a doubly linked list. And what that would allow you to do is you could go to a node and say, hey, what node was before me and what node is after me? So if this were a doubly linked list, each node would actually have a link to the next and the previous, like this. And we could traverse in either direction. We're just going to work on a singly linked list right now, though. So let's take these two little nodes that we created and put them into a list of sorts. That's the wrong thing. We are here. Now, if we go back to the Wikipedia article, let's see if it says anything interesting. More complex variants add additional links, allow more efficient insertion and removal, etc., etc. A drawback of linked lists is that access time is linear. Yeah, we'll potentially talk about that, but you saw on the diagram, basically, if I wanted to get the value on the end, and let's say I don't have a reference to the tail, I would have to start at the head, I'd have to go to next, all the way to the end. So it's linear. I basically have to visit each node to reach the end. You can see this is how Wikipedia is drawing it too. Okay, so I think that's enough. Let's just write some more code. So we have these two nodes here, right? We want them to point to each other. So if what I could do is I could say some node dot next equals some other node, like that. Just as easy as that. And then if I were to now log some node, and hey, Bogdanovich, thank you for the 1,000 bits. That's a lot of bits. So this is all I've done. I've basically added a new instance property to this node, to the one instance of the node. And let's actually say this.next starts off as null, right? So when you create a node, it doesn't know what the next thing is, but then it's possible to specify what the next thing is. So some node doesn't have a next, some other node doesn't have a next, but we say some node.next is some other node, right? And by default, this will have a next of null. So if we log this out, let's see what we get. Look at this. So we have the node. It has the data 42 inside of it. Its next property is a node that has the value 13 inside of it, and its next property is null, meaning we're at the end of the list. And if we wanted to do the same thing as our diagram, we could create one more, another node, and we put the value 7 inside of it. And then I could say, so some nodes next points to some other node, and then some other nodes next points to another node. And now when I log it, we go deeper and deeper. So we have a node up at the top that has the value 42. It points to a node that has the value 13. That points to a node that has the value 7. And then next is null. So we're kind of at the end. Great. So now you wouldn't want to do this manually all the time, right? So this is where we can create a class that kind of wraps and encapsulates all of this. So we have the node. Now we actually want a class for the linked list itself. So let's create a linked list. And this will be a class linked list. Wait, how's this work? Like that? Okay. And this has a constructor. And let's say I guess I don't even, what properties does it have? I guess a linked list should know what the head is, so it should know what the first node in the list is, and it'll also keep track of the tail. Let's do this. And so by default, when I create a linked list, it doesn't have a head or a tail, but then I could have a method called insert that takes in some data. This insert method would create an instance of a node that has that data value. And then I could potentially see if we have a head or not and set it there. But hey, Mike North, thank you for that sub. We're getting ahead of ourselves. Let's at least just get this going. So I'm gonna export this. Linked list. Yeah, there's a lot of things happening in the chat. This list is sponsored by Zelda. Link? Get it? I apologize if I've missed your messages, but we're gonna get this. Okay, so we have this linked list. Let's bring it in over here. And actually, we now no longer even have to know about the linked list node. We can just create a linked list like this. So I'll create a list called my list. It is a new linked list like this. Beautiful. If we log it, right now it just has nothing. It should have no head and no tail, right? So the head is null and the tail is null. But if I say I want to insert some data into the list, by default, this will just insert it at the end of the list. So I'll say my list.insert. We want to insert the value 42. And now we need to write this logic. So over here, we need to check some things. So first of all, we create a node. Easy enough. Now, let's take a quick stretch. The list could have a length property. I'm not opposed to that. Sometimes linked lists have a method called like count or something like that, and that actually iterates the whole list to keep track of the count. But yeah, why not? Let's just say the length starts off as 0. I like that. So now head is null, tail is null, length is 0. Now to insert, if you think about it, the first time we insert into a totally empty list, that node should be the head. So I'm just going to do some checks here. So say if this dot head is not a thing, then I'm going to set this node to be the head. So this dot head equals that specific node. And so now, whenever we insert, if there was not a head, that node becomes the head. Great. And very similarly, like whenever, and actually we could just do this here. So if there is no head on the list, then this node is actually the tail and the head simultaneously, because there's only one of them, right? It's the head and the tail. So we can see that this linked list has a head and a tail, but it's the same thing. And we now need to increase the length anytime we insert. So we'll say this dot length plus equals 1, like that. So we can now insert data. Great. But now we need to handle the case where, what if there is a head? We actually need to take this node, set it to be the next of the tail, and then set that node to be the tail, right? So it should work like this. So we insert 42, and then we insert 13. But if we look back at our diagram, so first we started off with this. This is the head and the tail. If we're going to insert the value 13, we need to say that the head next now points to this new node that we created, and then this new node becomes the tail. So let's do that. Okay, so we can insert, and now we'll handle this here. So if there was a head, then what we actually want to do is we'll just say this dot tail dot next equals this node that I created, and then this dot tail equals the node. So every time I insert a node, I already have a reference to the last value in the list, so I'm going to set its next value to be the node that I just created. And then I'm going to override the tail to be this node that I just created, because it is now the tail. And just like that, we have insertion. So we can see that our linked list has a head with the value 42. Its next value is a node with the value 13. And because that node's next is null, that is also the tail. And we could insert all day long. So now we can insert the value 7. And so now we can see, and it gets more and more nested, so we can't actually see that logged. Let's just do this. We'll do JSON.stringify. We could also do like utils with a depth, but this is fine. So I'm going to stringify the list, so that way we should see the whole thing. So our head is a node that has the data 42. Its next is a node that has the data 13. Its next is a node that has the data 7, and then its next is null because it is the tail. The way I logged it here makes it look like this node with the value 7 is actually separate, but let it be known that it's a reference. It's not a copy. So this node right here, this next one, is the same one as the tail. And hey, Soft Dev, thank you for that sub. All right, we have a linked list. We can insert data. That's great. Let it be known. And actually, if we look at the length is right. So if we insert something else, like the value 9, and hey, Soft Dev with the 9 gifted subs. You're too kind. Oh, no, and then one more, 10 gifted subs. Thank you very much, Soft Dev. Much appreciated. And hey, Danif, thank you for that resub. CJ is the real MVP. I appreciate you, Danif. Cool. So it works. What else do we need in our link? I think this is kind of it, right? I kind of just like hacked this together, but I mean, we're basically representing what's happening in this diagram in my code. We can insert. I mean, a lot of linked lists will implement like remove. I think it would be it would be good to implement remove from the list, so we can specify the index of the element we want to remove. Can I make it circly or doubly linked list? Let's do that first, right? Yeah, let's do that. I work at a company. Yeah, this is the first time I've streamed on a Friday in like months. Follow the tail? Oh, like the tail. Actually, you could, if you make it a circularly linked list, the tails next would actually be the head, because then you could just go in circles for days. But let's just make it a doubly linked list, because that's easy enough. So I'll say this.previous is null. So when you create a node, it doesn't know what the previous is, and it doesn't know what the next is. So whenever we insert a node, if there was no head, same logic, that node now becomes the head and the tail. And it doesn't have a previous because it's the only one. But now, yeah, so here's the tricky part. Whenever we insert a node, we have to find the previous one to add it as a reference. So this.tail.previous equals the previous tail. There is not sufficient disk space to continue recording. Well, we can fix that. Sorry, everyone, just a second. Wow, some of my stream files are 10 gigabits. That's a lot of data. Okay. That's enough. All right, I have decided I'm not going to do this because I can't think about how I would do it, but let it be known it would be possible. I would essentially have to traverse the list going from next to next to next until I get to the next to the last one, and then once I have the next to the last one, I know that that is the previous. Let it be known that it's possible, but I'm not going to do it. But what we will do is, at least let's just show how we might actually iterate through this list. So we have this list. How do we iterate it? So let's create a for loop. I starts at 0. We'll say I is less than mylist.length. Node.previous equals list.tail. True. But what happens with the head? I don't know. I can't think through it, and I need to be done very soon. So I'm just going to show that now that we have this data structure, we actually can iterate through it, right? Because we have, well, actually, it wouldn't. Can we do this with a for loop? We probably can. Yeah, we can do this with a for loop, because we can say let the current node equals mylist.head. So we start off at the head, and then we're going to iterate up to the length, and then, yeah, we'll say I equals 1. So let's log out current node dot value. And then I'll say current node equals current node dot next. So we log the current, well, and it's not value, it's data. Plus equals 0, yeah, you're right. That should be plus equals 1. So we log the current node's data, which is going to be the head, and then we go to the next one. So we'll say current node equals current node dot next, and then we log its data, and then we go to the next. And that should do it. And I'm Space Ducks. Thank you for that Twitch sub. Let's see. Will it work? I don't know. Is it gonna error? Does anyone want to place bets? Is there a way we can place bets with channel points? Do any of the mods know? I've never done that. I feel like it's a thing that we could do though. Yeah, I think I'll end with that, Tariq. Which basically, when and why would you use this? It's possible. Predictions? Where do I do predictions? Let's do it. Let's do it. We're gonna wager. You're potentially wager some of your points. Where do I do it? Is it in the dashboard? Seedlings? Slash in the chat. Prediction, okay. Hey, name the prediction. Will it work without errors? So if, okay, possible outcomes. Yes, it will work. No, it will error. You have 1 minute. Go. Wait. Yeah, and you can win channel points. Okay, here it goes. Let's go. Prediction started. Place your votes now, I guess. How does it work? I can't see it on mine. Win channel points if you make the correct prediction. Oh yeah, okay, I'll show the code again before you vote. So this is the code. So I have the list. I set current node to be the head. I iterate from 1 up to the length of the list. I log the current node's data, and then I set current node to be current node.next. Will this work? Wow, there are 22,000 seedlings for yes, it will work. 18,000 for no, it will error. This is fun. Wait, is that really a thing, Frozen Spray? You can't gamble invisible Twitch points? Doubting for the high return. I give it a 50-50. It's like a 50-50 chance though, right? I don't know if there's really any over under here, because I don't know. You could technically, someone could bet all of their seedling points. You could bet all of them, and so is somebody gonna write out the code and try and run it? X to doubt. Yeah, you could double up right now. You could basically double all of your points. Double or nothing. Yeah, I'm totally up for doing more predictions like this. All right, probably like 20 or 30 seconds left. This is basically a first try bet. Will it work on the first try? Because I haven't run this code yet. Well, it should. It should let us. What was I thinking? No, it should let you still vote, right? Can you change your vote? T13R is surprised that the length just works out of the box. Well, I added it, so at the end of the insert, I increment the length. All right, so people have voted. Let's run it. It works! I can't believe it works. Did we miss one though? 42, 13, 7. Wait. Am I missing a value? Didn't I insert 4 of them? No, we're missing the number 9. Wait, okay, so here's the thing though. Here's the thing. The vote was, will it error? It didn't say, is it correct? It didn't say, is it correct? So we're missing the number 9. So I actually think I need to go less than or equal to. And then, well, let's say it didn't error. It didn't error. No, it worked. The vote was, will it work or will it not work? Okay, how do I review predictions now? Okay, so 60% said, yes, it will work. 40% said, no, it will error. I think this is clear enough. It's clear enough. It wasn't, will it work correctly? It was literally, will it error? So it worked. There you go. Congrats to everyone that gambled your points away. This is rigged. Okay. I think this is it for linked list. If you learned something, can you just give me a smile in the chat? Oh yeah, I think we'll end it with like why and where is this useful. I'm out. So a linked list is a type of data structure. Now you'll notice. Hey, look at all those smiles. You'll notice that we can we basically created this data structure to hold on to a list of data, right? Now, in your day-to-day programming, if you're a JavaScript programmer, to do something like this, you probably would just use an array, right? So you'd say like my array is this, and it has the values 42, 13. 7 and 9. This is a data structure that's just built into the language. And it allows you to do similar things, right? We can push into the array, we can splice it and slice it, all that good stuff. But you might think about how is that thing actually implemented under the hood? And a linked list is another way of storing sequential, like linear data. Now, in terms of why you would use one over the other, typically, in lower level languages, an array is, what's the word? Contiguous in memory for the most part. Sometimes it depends on where it's implemented, but for the most part, typically an array is contiguous in memory, and you have to know the length of the array ahead of time. So let's just think about that really quick. So if we have this array that we're trying to store with the values 42, 13, and 7. Now, it's kind of like a little white lie because it varies on what language this is actually implemented in. I believe in JavaScript, I don't think it even works this way, but like in a lower level language like C or C++, if I wanted to create an array, first of all, I would have to allocate memory for that array ahead of time. Let's take a quick stretch. So yeah, it's a dynamic data structure. Basically, let's think like this. This is our memory, and our memory in our computer has a bunch of slots. With an array, typically you'd have to say, okay, because I want to store this array, I need to find some free space in memory with 3 slots. I'm going to allocate that, and then in those 3 slots, we're going to put the values in there, right? Great. Now, if I wanted to insert something into this array, like let's say I actually wanted to add the value 9, if this space in memory was free, technically I could just change the end pointer of the array to here and put the value 9 in there. But what if it's not? What if all of this memory is actually taken up? Typically, what you'd have to do is you'd now have to find a free space in memory that has 4 contiguous spaces. And hey, unfair, thank you for that resub. So let's say this is down the line, somewhere else in memory, and I find, let's say this is taken, but I find that this 4 spaces are available, so I'd have to allocate this, and then I would have to copy the values over, 42, 13, 7, and then I can put that new value at the end. So in lower level languages, this is typically how an array works. It needs a contiguous space of memory, and if you ever want to change the size, you typically have to copy the whole thing to a space in memory where it has space. Now, contrast that with a linked list where each node points to some other node. You'll notice that these don't have to be contiguous in memory. This next pointer can point to any memory location. So the way it ends up working out is, like let's say I have, and again, this is a gross simplification, but it's a way to think about this. So let's say that, and again, gross simplification, because in this memory, I'm able to store numbers. I'm going to say in this memory, I'm able to store a node in each of these little cells. But let's say I create a node. All I need to do is find one space for that node, allocate it, and then put the stuff in there. So we have that little box with the value 42, and then the next pointer, which is null. Now, I need another node. I can literally find any free space in memory. It could be anywhere. Like, let's do this. Like, let's say all this is taken up. But, oh, I found one. That's where I'm going to put this node with the value 13. And Termicus, thank you for the $5. Just watch my authentication tutorial. Let me read this donation. Thanks for that. Helped a lot. even though it was in view. Oh, you're very welcome. Okay, so I found a free space in memory. This is where we're going to put the value 13. And now this node, all it has to do is point to the memory location, right? It just says, hey, the next value is over there. So this is one of the benefits of using something like a linked list over an array. This is a dynamic data structure. The other thing is that I didn't talk about is like inserting into the linked list. So if I wanted to insert, again, like I want to insert a node between these two. And hey, awaited, thank you for the 100 bits. How does it work with garbage collection? Typically with a garbage collected language, if there are no references to that thing, it'll get garbage collected. So if I were to remove this next pointer, and nothing else references this object and like it's no longer in scope, it will potentially get garbage collected. Yeah, okay, but let's say I want to insert a node in between the two. All that memory is taken up, but I found one here. Let's say this has the value 8 in it. To insert this in between the two, I would basically have to override this next pointer, so I get rid of that one. I say that this one's next is this, and then this one's next is this. What's happening? Oh, Selvis with the 2-month resub. Thank you very much. So it's very dynamic in that nature, whereas with an array, if I wanted to insert a value here, I'd have to find contiguous space in memory. I'd then have to copy the values over and then put the value in. So this is one benefit of a linked list over an array. Now, what Hardik is mentioning right now is you have to iterate to the position, right? So that's a downside of this. With an array, you have instant access to anything you want. So typically with an array, there's a pointer that stores the starting location of the array, like the starting memory location. And then because you know the type of data that's stored inside of it, you can say, well, because I want the third item, I can take this starting location A, add 3 times the size of the data that I'm storing, and that puts me here, which is the value that I wanted to access. So you can just do a constant time, very simple math to pick out any value from the array. Constant time. Whereas with this linked list we implemented, if I want to get to the third element in the list, the only way to get there is to iterate. So it's a potentially an order in operation, because I have to start at the head, go to the next, and then finally I make it there. There's no way to randomly access the sum value inside of the linked list. In a traditional linked list, you could add something, you could add a mechanism for random access if you really wanted to. All right, I think I'm done talking about this. This is going to be a long YouTube video, and it's missing a lot of information. Thank you, Phoenix Rising. It's good. It's good to see you here, too. I would say search YouTube for linked list. You'll find 100 better videos, but I appreciate you all for hanging out with me and learning and all that good stuff. So what's the plus? That was what I talked about earlier. Basically, random allocation, I guess. And also, if you check out the Big O cheat sheet, this will show you certain data structure operations. So if we look at an array, access is constant time. Like I said, you just do a simple memory calculation, you can find any value in there. With the singly or doubly linked list, access is order in time, because we potentially have to visit every single node to get to a specific node. So this website is nice to compare and contrast the different ones. And when it... yeah, and so in our linked list we created, we're just storing numbers, but you could create a linked list that stores any type of thing. Yeah. Yeah, inserting at the beginning of a linked list is just as simple as inserting at the end. You just replace the head. Okay, I'm done. Thank you all for listening. I appreciate your attention, and thank you for voting and all that stuff. And this code will be pushed up somewhere. Okay, now we take a step back and we say hi to everybody, because I've been live for an hour. That was way longer than I thought I was going to be. Thanks for coming to my TED Talk. Yeah, exactly.